Hello and welcome. My name is Rahul. I'm working as an architect for HCL's via MyCloud. It is a hybrid cloud management platform by HCL Software. And in this presentation, we plan to show you MyCloud's profound capabilities of provisioning resources and services in Azure Cloud through a live demonstration. Besides Azure, it also has native integration plugins for key private and public cloud providers like VMware, AWS, and GCP. However, before we jump into this demo, we would like to briefly touch upon what else MyCloud is capable of besides just provisioning resources or services across a hybrid cloud landscape. So it offers self-service portal feature. This is where you can create new service catalogs and publish them for consumption by the enterprise users. MyCloud is an API-driven solution, so the published catalogs can be exposed in an API for consumption by the developers community or by the GitOps CI/CD pipelines or even by an ITSM solution like ServiceNow or Remedy. It also offers governance and approval policy features. This is where you can enforce guardrails on new provisioning requests that they must be approved before provisioning can continue. It also provides orchestration capabilities. You can design your workflows here, set execution sequencing, and also integrate with third-party solutions over REST API, SSH, or WinRM. So it provides a great level of flexibility here. It also offers multi-tenancy feature, which allows you to keep distinct access management and allocate dedicated resources or resource pools to different business units. It gives you insight on billing and costing information as well. This is a great insight on public cloud's billing information and also the cost of the resource or service that is being requested by the requester. So, this kind of information can be significantly helpful in operations, financial budgeting, and planning decisions. So, with all these basic features covered, we can now move on to the use case that we plan to show you in this demo. So, what we plan to show you today is the provisioning of multiple VMs that will be put behind a load balancer. They both will have a website deployed, which will then be accessed through a public internet. And the static website that we are deploying would be of MyCloud. So, towards the end of this demo, we plan to also show you by opening up both the websites that will, you know, bounce from one to the other one. So, the whole workflow starts here with ServiceNow. When the requester submits the request, the first thing that we MyCloud will do is it will initiate its integration with ServiceNow, which will then raise a change record. So once a change gets created so that we are in compliance with the policy, we will perform with the next sequence of actions through the orchestration workflow. We will leverage Azure integration. We will go ahead and create the resources on cloud. We will create two virtual machines on cloud and we'll spin them up. We will also configure the load balancer, create that service. We'll put both the machines behind this load balancer. And then as we go along in the workflow, we will invoke Ansible integration. We will have some playbooks created, which will perform some post-provisioning activities and tasks on the VMs that we are provisioning. We will deploy IIS website on both the machines, leveraging Ansible. And also leveraging Ansible, we will be invoking BigFix to perform build time patching on both the machines. And then again, using Ansible, Nimsoft Monitoring agent would be installed, which would be used for monitoring VM level services and report in case any of the services is not available. And towards the end of the workflow, we will update the CI information in the CMDB and we will close the workflow cycle, right? So with that, let's move on to the actual execution workflow that we plan to showcase you in this demo, right? So here, as you see in the middle, this is the catalog view of MyCloud Portal. This is where we have multiple services and catalogs published for the consumers. They can come here and request for those services. So from a UI's perspective, business users can log into MyCloud. They can access their service catalog, which is mapped to their role. And once they have that role access available for that catalog, the request can be submitted. The same catalog, like we previously mentioned, is also available for consumption through APIs. So if a developer plans to request the same resources or consume the same catalog, they can consume the same catalog through APIs. All right. So once we have that in place, MyCloud will perform the required orchestration. In this piece, before we move forward with the provisioning request or anything else, we have an option to add the approval mechanism as well in MyCloud. It is the native module within MyCloud, which we can leverage. Although for this demo, we're not showcasing that. However, that feature is available that when the request gets submitted by the requester or through an API call, that request goes to an approver, a valid approver. A valid approver reviews that request, and once they find everything all right, they move on with the approval, and then MyCloud starts with the actual provisioning cycle. So with this orchestration, there are multiple stages. We have pre-provisioning stage. This is where we generate a host name based on the information we received on the request form. So it could be unique based on the organization nomenclature for server naming. Based on that, these names would be created. We will also open up change request to perform any further action to remain in compliance. So we will leverage the ServiceNow integration, get that change created, and then move on with the further workflow. We'll prepare the network constructs. The first thing that we do is we leverage an IPAM integration like SolarWinds or Infoblox to reserve an IP address and also get the DNS record created, right? So in this case, we will be reserving three IP addresses, 201, 202, and 30, although this is just for the demonstration purpose, because when we are in Azure, we will be using the native IPAM of Azure for the IP allocation. So once the pre-provisioning task completes, we move on to the provisioning stage. So in this stage, we perform an actual provisioning of the virtual machines on Azure. We also provision the load balancers. We configure the rules, the backend and the front end rules, where we define the backend of both the VMs and the front end of the floating virtual IP, and also configure the NAT rules because both the machines will be on the private IP address. And to enable their public access, we will be configuring some NAT rules on both the machines. So once the provisioning cycle gets completed, MyCloud Orchestrator will kick off the post-provisioning task, leveraging Ansible. So here, Ansible would be responsible for installing the BigFix agent, to install the Nimsoft agent, to push hardline baseline for hardening baselines from BigFix, like patching updates will be done through BigFix. It will also install IIS. It will deploy a static website on both the nodes, and towards the end, the CMDB would be updated by Ansible. Or it can also be leveraged directly through MyCloud. In this case, we are not using Ansible. We are using a combination of both to achieve these different tasks, right? So once all things are in place, we have the CI record created in CMDB. We perform the change closure on ServiceNow and end the entire workflow. So once this request gets completed and we have all green, we will be accessing the URL for the load balancer. Although for this demo, we are showing this on the IP address. However, we also have capability to have the DNS record created, and we can also access these URLs on the actual FQDNs versus the IP address. So that's not a limitation. So since now you have a background of what we are going to showcase you, we can now show you exactly on the MyCloud portal that how this really functions and how this really goes. Here we are. This is MyCloud's landing page. This what you see here is the requester's view. I am logged in as a service requester. This is one of our AD credentials. MyCloud is integrated with our demo AD environment, and that's how the authentication took place. This is the landing page of which shows you the dashboard. It gives you great insights on what is going on in the environment from the requester's perspective. It shows the platform wise request, who which are running across different clouds. It shows OS wise provisioning request, how many VMs are running or not running. There are many more information if you keep scrolling down that are very helpful.
from anyone's perspective, be it the manager or the requester, so they can keep a tab or and check on what they're requesting and what they have requested so far. Okay, so I'm gonna quickly jump back to the request form. This is the request service catalog page, which we have to go to if we have to access the service catalog. And since MyCloud is capable to integrate with major private and public cloud providers, uh, and we have it all of them, configured in the demo environment. But since this demo is limited to Azure, I'm going to select Microsoft Azure as the endpoint and going to proceed. And this is the service catalog view, right? So this is the service catalogs that we have configured for Azure. All of them belong to Azure. They are readily available and can be used for Azure based provisioning. So if you can see, the list is huge, and there are many catalogs that we are seeing here. We have even categorized them in different categories like IaaS, PaaS, multi-machine provisioning, network services, Kubernetes services, so that you can simply jump onto these services and select which is most applicable for you. So in this one, we are going with the network services as we plan to show you a provisioning of load balancer with multi-machine provisioning. And I'm gonna go to this request form. I'm gonna request for it. And this is a very intuitive form from the requester's point of view. Since we have AD integration, the requested by field is auto-populated with the AD user information. If this request is for somebody else, I can enter this information. If I'm raising it on someone's behalf, I can select which application it belongs to based on different SOPs. It may have different function. It can be used for the server naming convention or even just for the tagging purpose, right? So I'm gonna select, let's say, Big Fix. This is the business category, which is auto-populating. It is also auto-populating the cost center. These information can then be added as a tag on the resource which we are creating. Then we have an option for the lease period, which is configurable from days, weeks, months to years. If it is just a sandbox environment and I just want it for like for 7 days or 2 days or something, I can just put the lease period here for 7 days or 2 days, and then the once the lease period expires, I will get a notification from my cloud that my resource will be uh, moved into the shutdown state, or however my SOP decides or dictates that, right? And then the decommissioning course will follow along again as we have it configured on the environment. Okay, so I'm going to move on to the next page. This is where I'm going to select the basic configuration, which is my region specific information, that which region it belongs to. It is going to belong to the resource group. This can be a hard-coded list, or it could also be dynamic list, which will be fetched from Azure, that we can show here on this drop down. We can select the load balancer name. It is a demo, so we are keeping it a very simple name, right? But this can always be configurable at the back end of MyCloud based on the inputs we receive on the form and based on the naming convention. This can be decided. The front end IP configuration, I'm going to choose one name, MYC LB Web01. We can decide the SKU for it, if it's going to be a standard network load balancer or a gateway load balancer. I'm gonna go with a standard one. And since this is gonna be a public facing load balancer, this is a selection that we have here for public. Um, it can be configured the way we want it to be done. Actually, this is specifically for the purpose of a demo, right? And then for tiering, we are choosing a regional deployment and not global. We can select the VNet. It's going to be the part of which subnet it will attach to. Again, these information, if requester is aware of these information can be put on the form, or they can be put inside MyCloud as a backend logic. Based on the user input, we can make those selections. We can keep the static assignment as static. This is prefix for the URL. So this is going to be a load balancer VIP. So it's preferred to have a URL and the domain. So with these information, we are going to create a concatenated FQDN for it. For example, in this one, it's going to be lburl.dryicelabs.com. Okay. Right. So with these informations captured, I'm going to move on to the next one where I have to define the backend pools configuration information. So I'm going to name them as MyCloud backend, web backend. Um, I can choose from different instance families. The two VMs that we are going to provision, I can choose from based on their different families. So I'm going to choose general purpose here for this demo. I can choose different instance size as well. I'm going to go with T2S V3 with two CPUs and 8 gigs of RAM. Again, which VNet or subnet they're going to be the part of, we can select based on the SOP. The number of VMs can be as much we like. We are just keeping it to 2 in this demo environment. However, this list can be rather long. With these basic information in place, I'm going to move on to the next one, the most important piece in the load balancing, which is the load balancing rules. Here, I'm going to define the name for the load balancer rule because we have the website that we will deploy will be a static website. It will be hosted on port number 80. So I'm going to name that port, which is relative to my port number of the website. I can select all these basic information like IPv4, what's going to be my protocol, TCP or UDP. It's going to be TCP in this case, port 80. My backend port is again 80. Um, and the health probes. We are using the standard health probe, which comes by default for HTTP. But again, this can be customizable, or this can be something which is already there based on the customer environment. We can also use that, right? So for the session persistence, I'm going to go with client IP. Uh, because when we show you towards the end, when we log into the web URL, we will differentiate based on the client IP. Okay. Okay, so with these settings in place, I'm going to move on to the next one. This is we can enforce some standardization. These tags are mandatory here, so we're not missing out on those key information on the resources before we have some, further automation that we have in mind or it's already running, right? So we are going to add a tag here for demo, MyCloud demo, and we can simply click on plus and get it added. Okay, so whatever I have filled in so far can also be generated as an output for in a JSON, which can then be used by my developers community. And if they have any CI/CD pipelines or if they want to test something with the Postman, they can always use it, provided they have the required credentials to make authorization requests to MyCloud. Right. So let me quickly show you that how this API JSON would look like in my IDE. These are all the parameters of our service catalog. As you can see here, these informations can be sent across in an API, and we will process that request similar way that we are processing this user request. Okay, so we have an option to review and confirm as well. All the settings that we have entered on the form can be reviewed, and then we can go ahead and submit the request. So this is my request number, which has been generated. Let me just copy it. I might need it again. And since I'm in the demo environment, I have the approvers access as well. We have approval module in place, and we're using the approval policies before any request goes through. So we're keeping all those checks in place. So this is the approver view. I'm logged in as an approver. Okay. All right. So here I go to my account, my approval. If I go to my approval, I can see this is the same request 937, which I had requested here. Okay, I'm gonna quickly approve this because I know this is from me. And we can also have different layers of approvers. As you can see, it has gone from my queue. And if we have like business, IT, or program team, they want to have approver layer of themselves in this whole process, we can have it in place and they can do the needful. Okay, so only when this approver approves this request or all the approvers in the chain approve the request, only then we move forward with the provisioning request. So we're keeping that those guardrails around the provisioning request before we do anything on the cloud endpoint. Okay, so if I have to track a request, it's again very easy for me as a requester. I can go to the my reports, request task management, and in request task management, I can select my organization. I'm part of HCL Dry Ice. To narrow down my search, I can select Microsoft Azure and simply click on Show Report. I can choose other options too. And great, we can see 937. This is the request which we have just submitted. And this request has is showing up here in my page, which means it has been approved and it is going forward in the provisioning cycle. So as this is the all orchestrated functions which are happening in the backend, which are happening transparently, unknown to the user. They just know what is the progress. So we have the web server name, which is going to be generated based on what we have put information on the form. All the pre-provisioning tasks will happen as we covered in the slide earlier. The provisioning of the web servers will happen, web server 1, web server 2. We will deploy the demo website on each server using Ansible, right? We will configure the load balancer as needed, configure the backend pools, attach VMs to the LB. So as you can see that we have a sequence of execution happening on in this workflow, right? And towards the end, we have big fix patching happening as well as Nimsoft monitoring. These two agents will be installed by Ansible on both the VMs. And once done, big fix patching will start and all the patches, the security vulnerabilities will be taken care of. And once we go towards the end of the workflow, as you can see here, the CI details will also get updated. We are also updating the CI in CMDB, so we are remaining in compliance. If any service request or any incident has to be created for that CI, it can be done right after the provisioning is completed, right? So we are trying to follow the entire process, which is typically followed in ITSM for any new addition of an object or in the inventory in the cloud landscape. Okay, so this is the end of the workflow for us. All right, so we are back on MyCloud Portal. This is the request which we had submitted, 14937. This request is now fulfillment completed. And let me quickly expand this request so we can see all the tasks which were executed in this workflow, right? So all these tasks were executed in this fashion. And what we plan to show you is we plan to show you the evidences on each of those integration points that what was done in each task, right? The first thing that we did was the opening up a ServiceNow change request. So we have a change request reference number here. If I click on this hyperlink, we have it for the user's information that they can come back here and look at the reference number anytime that they want. So let me copy this, although I already have it on ServiceNow open. This is 735173. This is the same change ticket number that we have here on MyCloud. So this is a standard change that was opened by MyCloud. This was the integration account that we used, and status, as you can see, is closed because this request was successfully fulfilled, right? And if I go further down, you can see the description that it was created for the creation of the public load balancer from MyCloud on Microsoft Azure, right? So this change was created so we remain in compliance with the process, and with that we move forward with the next sequential tasks, right? So once we have the change in place, it is in approved, we are good to go and provision the web server 1 and web server 2 on Azure, and then we deploy the websites on both the VMs, right, using Ansible. So the next tab I already have open is Azure. This is where I am going to show you the virtual machines which were created. This was the name that we have used for both the VMs, LPVM 14937. So 14937 correlates with the request number 14937, right? So it's a quick reference, and we can see N1, Node 1, and Node 2. These both VMs are in the running state. They're running in East US 2 region, and they both are on Windows and have a size of D2S version 3. Okay, and furthermore, if I'll take you into this VM, when we had submitted this form, if I go back to this hyperlink, um, this is the information that we have filled on the form, and the last tab is the tags information, right? So this tag is the one where that we had appended on the form, right? So, and the remaining tags were enforced by the form, right? So we are enforcing some control in the whole process, and all these tags, the mandatory tags and the optional tag, these were added by MyCloud, and we can see them here in both the VMs under tags information column. This is demo, which was added by us, and the other tags were also added by MyCloud. And the same goes to Node 2. Let me quickly go back to its tags section, and these tags were updated correctly, as you can see. Okay, so next in the sequence, if I go back to my workflow, let me close this page. And here, what starts now is the load balancer configuration. The deployment of the demo websites was done by Ansible, but we plan to show you that towards the end, right? So the LB configuration was done, which was the next step on back to Azure and to the load balancer page. We have a single load balancer. This is the name that we had chosen, MyLab01 on the form. And in this load balancer, we can see the front end IP configuration. This is lburl.dryaslabs.com. If I quickly take you back on the form on MyCloud, um, and if I click on this hyperlink and go to the front end IP configuration, this was the prefix lburl and the domain dryaslabs.com. And we had mentioned that this will be concatenated by MyCloud, and this will be used as the name of the load balancer VIP. And the same you can see here. And the IP assigned is .71. This is going to be the IP that we will be using today to access our websites, right? Then after the front-end IP configurations, we have backend pools. In the backend pool, we can see that both the VMs Node 1 and Node 2, they're added in the backend pool. They both show in the running status. We have the port 80 health probe configured on this. With this name, we have the load balancing rule to uh, you know do the load balancing on port 80 on TCP for the backend pool that we have configured, right? So all the relevant and the required configuration for load balancer was completed successfully by MyCloud, right? And if I go back to MyCloud and close this page once again and go back to the workflow, the next in the sequence is the Nimsoft monitoring and the fix patching. And if I take you a little to the right, you can see number 17. This is the sequence of this execution. So 17 for all tasks means that this was done in parallel for both the machines, right? For VM1 and VM2, right? So I'm going to first show you Nimsoft console. This is the Nimsoft console that you can see here. I will go to its inventory, and Ansible went ahead and installed the agent on both these machines and also made sure that both these agents were onboarded to the Nimsoft console. So we can see Node 1 and Node 2, they are added here as well. We can see them. We can see their OS details. We can see their IP address, their private IP addresses, which are configured, right? And if I'll just open up any one of them, let me open up Node 1. You can see that they're also getting monitored on their CPU and memory. And there are no open alarms at the moment. In case we bring this VM down, we will see an alarm getting generated. And if we have any integration with any MOM layer, the subsequent processes can follow, right? So this was about the Nimsoft piece. The next in the sequence was BigFix. Let me quickly bring up BigFix screen up here and go to devices. Here we should also see both the VMs getting reported to BigFix, because Ansible, when it installed the agent, it also made sure that both the VMs were getting onboarded to BigFix. So let me search with the computer name LBVM, and yes, we can see both the VMs here, N1 and N2, right? So the BigFix agent is detected. Both are on Windows 2022. They're getting discovered properly. We have the agent installed on both of them, right? And they were recently discovered as well, almost 10 minutes ago, right? So this was the big fix task. Let me quickly switch back to MyCloud and see what happened next. This is the load balancer add CI details. So this is where we added CI details on CMDB. So in this demo, we have just made one CI entry for load balancer, although we could do the same for the web server 1 and web server 2 as well. But just to show you the capabilities, we are just showcasing that for the load balancer, right? I have that open as well in another window. This is the name that we had selected. If I go back to my cloud, go back to this hyperlink and look at the form that what we had filled in the front end IP configuration, you can see the load balancer name that we had selected was MyLab01. We can see the name here. We can see the serial number. We have used the same information as serial number as well. This is the IP address which is configured on the load balancer that we had seen on the load balancer configuration in Azure in the front end IP. Just for quick reference, this is .71. We have the same here as well, right? We can see that it is in the correct category, correct subcategory of load balancer. We can see it is in the installed in the deployed status, right? So the CI record is also taken care of. Now let me quickly close this. No, before I close this, this is the public IP, public URL that we can use to open up our website that we hosted. Okay, all right. Okay, perfect. So it has landed on the Node 1 VM. If I refresh this page, it has switched over to Node 2, right? So that confirms that the load balancing is working fine, right? And the configuration which was expected is working fine as well, right? Let me see if anything else is left in the workflow. No, I think it is done. The last thing is the closure of the change request, which we have already shown you in the beginning, that the change was also closed by this integration with MyCloud, right? All right. So with this, it brings us to the end of this demo, and we really hope that this session helped you understand and learn about MyCloud's capabilities and all the possibilities that it offers as a cloud management platform.